Hey guys, welcome back to Jump Mathematics. In today's video, we're going to be talking about variables, what's a variable, and how do I use them. We're going to run through how to solve equations, especially word problems. Now they might seem scary, but they're not actually that bad. They're just a problem that isn't summarized. Then we're going to talk about substitution, independent and dependent variables, so two different types of variables, how to solve two variable equations, and what are like terms. So first off, what is a variable? A variable is just a letter that represents a number. It's as simple as that. So let's use the letter x, and let's set it equal to, say, 5. Okay, so now I know that x equals 5. So if I'm told to evaluate the expression, what is 10x, I know that the answer is just 10 times 50, or times 5, which is just 50. It's as simple as that. So now we're going to run through how to solve an equation just like this one. And when you're told to solve an equation, it just means try to find the variable or the number that the variable in the equation represents. In this case, we're using x. So I'm going to start by simplifying. So right here, I can tell my PEMDAS, this is parentheses first. So I'm just going to leave 7x alone, minus 3 minus 4 is negative 1. Just like that. Equals, now I have to simplify this side. I'm going to leave 13x alone. And, oh no, what's 6x plus 3? We don't know yet, because we don't know what x represents, so we can't add that. So this is why the distributive property exists. I'm going to distribute 5 to both sides. So I get plus 30x plus 15. Now, I can simplify this right here. What's something minus a negative number? Well, that's the same as right here. I can just distribute this negative to that negative 1. 7x plus 1 equals, now I can simplify this side over here by adding 13x plus 30x because I know x is the same. So 13 plus 30 is 43, x plus 15. Now what do? Well, I have to get all the variables on one side and all of the numbers that aren't that variable on the other side so that I can divide by a coefficient in order to find what only x equals. So I'm going to subtract 15 from both sides. And I can only subtract it or take the difference of the numbers that don't have an x in them. So I'm going to get 7x minus 14 equals 43x. Now I have to do the same thing with the x's. And I'm going to move the 7x over to this side. So I get negative, well, I'm going to subtract 7x from both sides. I'll do that first. And I get negative 14 equals 36x. Okay? Now what do? I have to divide both sides by this coefficient, 36. This is what I was talking about earlier, because I know that 36x equals negative 14, but I still don't know what x is. So I have to divide by 36, so I'm left with just x. Divided by 36. And I'm going to move the x over to this side, just because it's nice to have the x on the left side. X equals negative 14 over 36. We can simplify this. Factor of 2 goes into both of them. So I get x equals negative 7 over 18. That's my answer. So now let's go through how to solve a word problem. And word problems might seem kind of scary because they have all this writing, but it's really not that bad. You just have to read through it, pick the most important things, and answer the question. So let's do exactly that. Step 1, read through it. Max Air Trampolines pays one employee $9 for every hour she works. If that employee works for 8 hours, how much money will she make? So now I kind of know what they're asking me. So let's highlight some things that we think would be important in answering the question. So $9 for every hour. That's her wage. That might be helpful for me to find out how much she makes. Now 8 hours, That's also very important, because if I don't know how long she works, I can't know how much she makes. Finally, one of the most important parts of this question, how much money will she make? That is the question, and we have to make sure our answer or our final solution answers that question. So, let's start by just writing down some variables and stuff to make a standard, equation to find how much money someone makes. So, let's use the variable P equals their total pay. So that's how much someone makes at the end of the day or at the end of their work shift. So then let's also have another variable. We'll use T. And that's going to be the time that they work in hours. We want to make sure our units match up. Finally, we'll use R to represent the rate. And this is just their wage. So I'll go rate/wage. It's how much money they make per hour. So now we're ready to set up a standard expression or equation that gives us how much money someone makes depending on the time that they work and the rate that they earn. So, and that makes sense because if the rate is in dollars per hour and I multiply it by time, hours are going to cancel out and I'm going to be left with dollars. So next, we need to substitute in for the variables. What is T? Well, they said right here, T is 8 hours. So I'm going to replace this with 8 hours. Now, what's R? R is just $9 per hour. Okay, so now I have $9 per hour times 8 hours. I don't know what our total pay is, so that's our variable that we're trying to solve to answer this question. So I have P equals 9 times 8. We know hours cancels. So we're left with dollars. That's good. 9 times 8, 72. So that employee earns $72 for working 8 hours. Now that we've become pretty used to variables and one variable equations, we're going to introduce two different types of variables that are especially useful in graphs and the rest of algebra. So first up, an independent variable. It sounds exactly like how it is. It is independent of everything else in the equation. Just like an independent variable, dependent variable sounds exactly like how it is. We use these two together to be able to change this to be whatever number we want it to see what this becomes. So now we're going to talk about two variable equations. So, in two variable equations, generally you have one variable that is your independent and one that is your dependent. So in this example, x is our independent variable. In our dependent variable, you guessed it, it's the only other variable, y. Now why is x our independent variable? Because we have it set equal to a number, so we're going to see what y equals when we pick what x is. So, let's substitute 5 in for x, because we know x equals 5, so we're going to say y equals 13 times 5 minus 4. So, as you can see, we're trying to solve for y. Let's continue by simplifying by multiplying 13 by 5. So now all we have to do is subtract. This is our answer. We can pick a different number for x, so say we choose x to equal 1. That's an easy number. Y equals 13 times 1 minus 4. Y equals 13 minus 4, and y equals 9. This is why y is the dependent variable, because we can choose anything we want for x, and we can see what y equals at the end of it. So to finish, we're going to talk about like terms. So what are like terms? They're really just terms that have the same variables and same exponents. So like just means the same. So it's basically just the same terms. So for example, if I take x, I can add 5x, and I get 6x. These are like terms because they have the same variables. Coefficients don't matter. But if I take x and try to add 5y, that's just x plus 5y. Because I don't know what these represent, and they're not like terms. So I can't have 5xy or 6xy, because that's like saying an apple plus 5 bananas is 6 apple bananas. We know that's not true, it's just an apple and 5 bananas. So we have to leave it like that. In much the same way, it happens with exponents too, even when the variables are the same. So if I take x squared plus 5x, I'm just left with x squared plus 5x, because these aren't the same even though they have the same variable. If I wanted to get 6x squared, I'd have to take x squared plus 5x squared equals 6x squared, because these are like terms. Hi guys, if you enjoyed this video, please check out jumpmathematics.com, where we have hundreds of practice problems, several practice tests, and tons of instructional videos all for free. Thanks for watching, and I'll see you in the next video.